Welcome back. In the last section, we cover the portion on decision tree learning algorithm. We're going to move on from there and start looking at regression. Okay, how you can apply decision tree onto a regression or continuous data. So we will start with from scikit-learn. We import the tree, same as before, no change there. And I'm gonna give you give it some simple data to train just to illustrate the concept. 0, 0, as well as let's use 3 and 3. Okay, so this is our x. For our y, we're just gonna use 0.75 and also 3. Okay, so we have now our basic training data. So we're gonna have our classifier, but probably shouldn't call it classifier anymore. We'll call it all right, tree regression. Okay, tree regression is equal to the tree, and we have decision tree regressor. Again, we're just gonna set the random state, and we use it 42. Right, let's instantiate that. And the next thing we want to do now is our tree regressor is equal to the tree regressor, and we're gonna use fit the data, fit our x and as well as our y. All right, so that's it. That's really done. The next thing that you really want to see if this has how this has performed or will perform, at least just to get a rough gauge, is to actually have an idea. We're gonna try giving some data that we think is somewhere in between. Let's just say 1.5 and 1.5. Now let's see, it's not callable because we already fit the data, we already conducted this. Well, the missing bit is the predict. Okay, and it tells us that it fits into the 0.75 class. And that's it. That's really, again, the basic simple steps. It's very similar to the classifier. The only difference is that now we actually are using the decision tree in a regression setting. So let's just borrow some codes from the scikit-learn library just to quickly do some visualization. I really don't want to actually tap up the whole thing. I just want to quickly walk through it just so that you can see what it looks like in a regression setting. Again, what they've done here is that they've generated some random numbers. Looking at this, you have 80 random numbers being generated and also a sine wave here. So basically you have y is the sine wave, x is actually the data that's being randomly generated data. And we fit two regression model. Okay, one is 2. Okay, so meaning the level, the depth of the tree is 2. The other one is 5. And when we run this, so the rest is just plotting really. So if you look at this, I'm just going to change the fixed size so that it's larger and easier to visualize. Okay, looking at this, you have the max depth of 2 is this one here. Okay, it doesn't fit the actual data as well. But when you look at max depth of 5, it is clearly overfitted. It's all over the place. It's trying to actually fit into every single data point. Hence, you have this problem of large variation. And the underlying data is this one here. It's the sine wave, with the exception that we added some noise in the middle, and the decision tree tried to actually fit into all of the data. So having done that, what we've done now is that we have looked at the maximum depth of 2 and maximum depth of 5. Now, how do you overcome this problem of the fact that it's trying to fit everything? Well, there's one option. Let's just copy all of these codes. Okay, and the slight variation we're going to make here is that we're going to have the minimum sample leaf is let's just use 10. All right, and we run that, and got a nice unexpected minimum samples. Okay, notice that the maximum depth of 5 now, it's substantially better behave than before. because previously what we have was that it's trying to actually fit everything, and because it actually segregated down to even a sample of 1, it will still accept that. So I guess I should really label this is this is really another form of regularization. Okay, and this is to illustrate the fact that because of the challenges or the problem that may come with decision tree, which is overfitting, you have to actually apply some basic common sense rules. In this case, we have applied the minimum sample leave to be 10. Now, if you recall, the minimum sample leaves basically means that this sample here must have at the very least 10 here. So this will never exist, our sample of 3. So by the time we get to 6 here, it would have stopped already, instead of allowing it to actually continue to keep splitting into smaller and smaller leaves. Okay, right, having done that, is probably a good exercise right now to extend further, is that again we're still going to look at, I'm going to come back to this maximum depth of 2 and 5 and look at this overfitting, and we're going to do visualization of the tree that we did before. So I'm going to export this, export graph viz, and we're using provide as an input the regressor, and the out file we're going to set it to none, and I like my chart pretty, so I'll put field is equal to true, and then rather than having multiple lines, graph is equal to graph viz dot source and dot data from above, and we're gonna plot the graph directly so that we can visualize. Okay, so looking at this, you can see that it actually goes down to a sample of 1, and that's why we actually have that problem. But in this case, we probably shouldn't be using tree regress. We should be using regress 1 and regress 2 here. Okay, so for this part, I'm gonna have that, plot that, and add and regress 2. Just let me take some time to explain this a little bit. That's way too big, but if you look at this chart, what do you see? You have the sample of 80. All right, the mean square error is 0.547. Notice that it actually has adjusted to regression, the actual matrix to measure the performance of your regression. It's using mean square error 0.547, 0.231, 0.124, and that's really one of the key characteristics of this tree now, is that because it's a regression based and continuous variable, you can actually see the actual how it's actually split. And this is the one that with 5, maximum depth of 5. This we actually restricted to level 1, level 2, two depth level. And if you look at the this tree here, you can see that it actually, well, it basically have a sample of 5, 4, 1. It's no wonder that it actually overfitted, because we allow it to actually just keep on growing a little bit out of hand and without actually restricting it altogether at all. And what happened if we actually regularize? So let's just copy these codes and save ourselves having to type everything again and run this. Okay, and again we run regression 1. Actually I'll just run regression 2. The reason is that 1, which is the max depth, 2, it's no change from before. Let's plot the max depth of 5, but this time around with the restriction or regularization, which basically only set the requirement that the number of samples in each leaf node must be at least 10. And looking at this, the tree is a lot prettier now than before, which is way overgrown, and you notice that it stopped when the sample is no longer when the sample is 10. It doesn't actually have any you don't see any observation whereby the sample dropped below 10 at all, and the tree is a lot more well behaved compared to what we had before. Okay, having done that, now I'm just like to actually give this a try yourself. I'll give you an exercise. The simple exercise really is to change this random number and increase it. Okay, increase it to 200 and see what would actually the result be. Would the 2 maximum depth of 2 perform as well, or the other one is the so-called max depth of 5? Is the regularized method better, or without regularization? So I'd like you to actually pause the video now and try that out, just to actually get your hands dirty and play around with the data itself. I look forward to seeing you in a minute. Welcome back. I hope you actually gave that a try and actually just really develop some intuition on that, and also plots the tree visualizer as well, just the tree viewer, just to actually look at and try to read the actual how the node and branching as well. With that, I'm going to end this lesson. The next lesson, we're going to move into another topic called problem with decision tree. With that, I'm going to end this lesson and look forward to seeing you in the next video. Thank you.